Okay, hello. This is just a video basically on the GCSE paper from Edexcel. It's paper 1, 2022, and I'm not going to go through the whole paper. I've had interesting discussions actually with some people about copyright kind of issues and stuff like that, and it's something I must admit I've never really thought much about, because I was under the impression, perhaps quite incorrectly, that copyright was, as a teacher for past papers anyway, it was not a problem. But yeah, perhaps it is. So I wanted to be slightly careful. I am of the opinion though that I think this is right to say that you can't really copyright a maths problem in and of itself. I mean, otherwise I'll take the copyright on 1 + 1 = 2 and make some serious money. So if anybody ever uses that, that's my equation, and you can pay me some cash for using it, royalties or whatever. But anyway, let's start with the first question, which actually I'm just trying to line it up. I've got these circles which I'm doing here. The thing is, you know, as tends to happen after maths exams, some of my students sort of run down the stairs like after they finish, go, "Mr. Nichols, there was an impossible question on there," and it's like, yeah, impossible. Well, it's probably just a difficult question, and sure enough, this was no different. And this particular question, as soon as they described it, I thought, this sounds so similar. So similar. There's a question in the A-level textbook where you've got two circles. Essentially, if I can just remove one of the circles here. Like, the reason why I got quite excited when they mentioned the question is I thought this sounds exactly like this question from A-level. It's in the back of an A-level textbook where they ask you to find the intersecting region here when you've got, bearing in mind you've got two circles which go through each other's centres and the radius of each circle is 4. Well, this is such a similar question because you've got exactly the same radius of the circle, 4 centimetres, except you've now got to find not the shaded area in between them, but the sort of shaded area at the top and the bottom of the middle circle. But it is incredibly similar, this question. So as soon as they mentioned it to me, I thought, yes, I've done this kind of problem before, and I'm immediately ready to sort of like, I knew what the secret was straight away. And the secret, like with any complicated geometry question, is to draw some lines on the diagram. Own the diagram. The diagram is yours to annotate. So that's exactly what I'm going to do here. And when you start drawing the lines and really thinking about it, well, that line must be 4 centimetres. That line goes from the centre to the edge of a circle of radius 4, so it must also be 4. And the same with this line as well. I'm sorry I'm drawing it so wonkily there. It looked so good at the start, didn't it? That line is also going to be 4 centimetres. In other words, this is an equilateral triangle because all of those lines are radii for a circle centre 4 centimetres. And so you know that this angle is 60 degrees. Yeah? Okay, brilliant. Right, that's a massive, massive, massive start. And I would be surprised in this question if you didn't get 1 mark for finding the area of that triangle there. I'm certain you'll get 1 mark, maybe even 2, for getting all the way to it. Because the secret for this question, if I can just give you a top-down overview, is I'm going to work out the area of the middle circle, which isn't a problem because the centre circle is obviously pi r squared. If I just call it the circle in the middle, it would be the same for the other circles though. It's just pi r squared, so it's 16 pi. Yeah. Now here's my strategy. I'm going to now take away from that 1, 2, 3, 4 triangles, and then 1, 2, 3, 4, 5, 6, 7, 8 segments, or seggies as I call them. Now those little seggies are the hardest bit of the problem to actually get the head round, but it is a very common question in GCSE, I've seen it asked a few times anyway, to be asked to find the area of a segment of a circle. Yeah, and essentially you do sector minus triangle. Seggy equals sector minus triangle. Yeah, that's always the way you do it. So that's going to be my overall approach. Is it difficult? Yeah, you know, it's a multi-step problem and it takes a while. Is it impossible? No. Is it difficult in exam conditions? Yes. You know, like so I know most students will probably not get the answer here. Anyway, let's work out the area of a triangle. Well, it equals a half AB sine C, and you're going to have a half times 4 times 4 times sine 60. Now, they did say you were required to know your trig identities here, and sine 60 is √3/2. So we're going to get 16 times a half, which is 8, but then I'm going to multiply that by √3/2. So that is 4√3. Good, I've got the area of a triangle. Now, the area of the seggy is more difficult, because like I say, you need to do sector minus triangle. Now, what is a sector? A sector of a circle is just like a pizza slice. That's the way I describe it. It's a pizza slice. And if we're looking for, if I can possibly draw it in red here, the area of that sector there, yeah, you can also see here why it's segi equals sector minus triangle. Well, if I'm working out that, that's just 1/6 of the whole circle. And so all I'm going to need for that is 16 pi, because that was the area of the circle, divided by 6. And the area of the triangle, I've already worked out, it's 4√3. So just to simplify that, that's 8 pi over 3 minus 4√3. Right, I can now do this because the answer is going to be given by shaded area equals circle minus 4 triangles minus 8 segis. Can I write it like that? I know it looks a bit silly, but that's the truth of it. 4 triangles will be 16√3. Now 8 segis, make sure you put this in brackets. Students don't use brackets enough, but 8 pi over 3 minus 4√3, don't forget to times it by 8. And now we should end up with the answer, which isn't too bad in the end. So that's 16 pi minus 16√3. We've now just got to get the algebra right. Minus 64 pi over 3 plus 32√3. And so we're going to have 32√3 minus 16√3 is 16√3. This 16 pi is like 48 pi over 3. And if you do 48 pi over 3 minus 64 pi over 3, you're left with minus 16 pi over 3. And that's the shaded area. And it's done. Whole question's done. Right, let's look at some more nasty questions on this paper. I'm just going to kind of like write them down because I don't want to like get in any trouble for infringing copyright. Like I said, the reason why I do it really is because surely students should be, you know, like the best time to get feedback is as soon as possible. And it's good to have feedback because you learn from it and you realise where you might have made a careless error or something like that. But I do think as well it should be, you know, available to everyone really. Like I think it's really important to you know, help students learn. But okay, the centre of the circle is a point with coordinates minus 1, 3. So this is the centre of a circle. The point with A with coordinates 6, 8 lies on the circle. So A, which is 6, 8, lies on the circle. They didn't give you a diagram, did they? Well, let's actually draw one ourselves. It's so important drawing pictures in maths. It really is. Like, I'm not a fantastic artist by any means. I'm really not. If you've seen some of my early artwork, you would definitely agree. But you know, draw a little picture of these things and get things loosely in the right place. So 6, 8 will be to the right and higher than minus 1, 3. Now we've got to find the equation of the tangent to the circle at A. So I'm going to draw a straight line there. There we go. We've got to find the equation of that tangent. Now this kind of question is very typical actually. Very typical. The way I advise my students to do it is work out the gradient of the radius first. Let's call it m little r. And you can do that by just forming a little triangle, really, can't you? It's going to be rise over run. So that's 5 over 7. We can see the gradient's positive because we carefully wrote down where that point was in relation to this point, a bit to the right and a bit up. And so you can see the lines going up, and so the gradient should be rise 5 over run 7. And that means that the gradient of the tangent, well, that's going to be perpendicular, and so that's going to be minus 7/5. Now what I can do is just use, now it depends, if you're familiar with y minus y1 is m times x minus x1, that's probably the quickest way to do it. But I tend to find that GCSE students don't like that. They, you know, prefer to use y equals mx plus c. So okay, I'll use y equals mx plus c. So y equals minus 7/5 x plus c. You now need a point on the line. You can only really use 6, 8 for that. So 8 is 6 times minus 7, that's minus 42 over 5 plus c. So that's actually like 8.4, isn't it? And if you add it onto there, it's going to be 16.4. Or if you prefer, this is 40 over 5. Add on 42 over 5, you're going to get 82 over 5 for your c. And now we can say y equals minus 7/5 x plus 82 over 5. All we need to do now is put it in their form. So I'll times it by 5. 5y equals minus 7x plus 82. Or if you like, 5y plus 7x minus 82 equals 0. And it's done. what we got next? And I'm just going through the difficult questions at the end really here. This is what this video is going to be about, just the tricky questions at the end. I'm not going to do the easier ones at the start. I don't really see much point. Just with the answer on those, you can normally detect where you went wrong. Okay, so 1 over 2x minus 1 plus 3 over x minus 1 equals 1. And you've got to solve this, yeah? Now, I think probably the easiest way, if you ask me anyway, is to just go straight out and times by x minus 1, 2x minus 1. You might want to combine the fraction at first. Please be my guest if you want to do that. But I must admit, I like to get on with things now. So I just like to times it by that. It's going to be quicker like this. You're going to get to this stage anyway eventually. If we times this by x minus 1, 2x minus 1, we're going to be left with 3, 2x minus 1. And then on this side, we're going to be left with x minus 1, 2x minus 1. Now really here you've got no choice. You're going to have to expand the brackets. So that's what we're going to do. And here we're going to get 2x squared minus 2x minus x, which is minus 3x plus 1. So we get 0 equals 2x squared. We're going to have to take away a 6x, which makes minus 9x, and take away an x, which makes minus 10x. And then we've got minus 4 here, which we're going to add on to the 1. So that's going to become plus 5. And so we've now got 0 equals 2x squared minus 10x plus 5. We've just got to solve this. Now the quadratic formula says that x equals minus b plus or minus the square root of b squared minus 4 times a times c, and 4 times 2 times 5 is 40. I think 4 times 2 is 8 times 5 is 40, yeah. Over 2a over 4. And so you've got 10 plus or minus root 60 over 4. But it's always nice if we can cancel that down, and also it'll be in their form, because they asked for the answer in the form please plus or minus root cube over 2. If we can now write that as like 4 times 15, we can see that this is 10 plus or minus 2 root 15 over 4. And so that is the same as, no, just half top and bottom, 5 plus or minus root 15 over 2. And that was question 19. Have we got time for one more in this video? I think we have. There's always room for another little cheeky question. Okay, so what have we got? We've got, this is question 18 by the way. We've got 5 and 4/9 to the power of minus a half multiplied by 4 2/3 over 2 to the minus 3. So there's a lot going on here, and it's really easy to mess something up on the way doing these ones. But when they come up in non-calc papers, you should expect it to be quite nice. Firstly, turn this into a top heavy. 5 times 9 is 45 plus 4 is 49. Over 9 to the minus a half, and that's good because half is square root and minus is turn upside down, so that should be easy enough. This is 4 times 3 plus 2, 14 over 3 over, and should we make this 1/8 straight away, you know, because 2 cubed is 8, put a minus in there, you get 1 over 8. Okay, now what we're going to get here, turn upside down, 9 over 49, square root 3 over 7. We've got 14 over 3 here, which is kind of nice because the 3's cancel and the 14 over 7 becomes just a 2, all over 1/8. Now ask yourself, how many 8's fit in 2? Well, there's going to be 16 of those. Yeah, because there's going to be 8 8's in 1, and so 16 8's in 2. And you've done it. Do we have time for one more cheeky one? Proportional question. It's pretty boring really. I was hoping for one which would be a bit more. 16 looks interesting. Or maybe I'll do 17, 16 then. Maybe I'll do both of them. So we've got y is directly proportional. So y is directly proportional to the square root of t. And obviously that means y equals k root t. We've got t is inversely proportional, so 1 over the cube of x. So t equals, let's use a different symbol now for this constant of proportionality. Let's use k hat over x cubed. Yeah. Now they also told us that y is 15 when t is 9, which means I can find this equation because I'm going to have 15 equals 3k because square root of 9 is 3, and so k is 5. So now write down the equation, y equals 5 root t. I can do the same thing over here as well because they told us t is 8 when x is 2. And so you've got 8 equals k hat over 8. So it looks like k hat equals 1. Yeah, I've written 8. I said 1, but I wrote 8. Hang on, what am I saying 8? Anyway, k hat is 64. It is funny when you make a mistake, isn't it? Probably not when it's in the exam though. But I have the luxury now of making mistakes and it not mattering at all, apart from the fact that I lose a little bit of respect from my students, but there was never that much in the first place anyway. So, okay, we've got to find a formula now. Oh, let me write down t, 64 over x cubed. And now it says find a formula for y in terms of x. This is a bit more interesting than I thought it would be. Find formula for y in terms of x. Okay, sure, cool. Okay, right, so I need to eliminate t, yeah, because t's in the way. Let's get rid of t. Lots of ways of doing this. If you've done like parametric equations, because this is a parametric equation, if you've done parametric equations at A level, this is significantly easier. I'm going to square both sides here to get y squared is 25t, because then what I can do is I can just plug this 64 over x cubed in there. So I get y squared equals 25 times by 64 over x cubed. A little bit of a shame that I've got to work out 25 times 64. Oh, I tell you what though, what I could do is actually square root now, because you could kind of square root everything on the right hand side. It would mean that I don't have to do 25 times 64, which my tiny brain can't handle. Okay, so I need to square root the 25 and I'll need to square root the 64 over x cubed. And that's just because root AB is root A times root B. So, okay, right, let's do it. Square root of 25 is 5. Square root of 64 is 8. And then that will be over x to the 3 over 2, actually. And so that's going to be y equals 40 over x to the 3 over 2. Now, it is possible that you might have expressed that in other ways. I do wonder as well, oh, they did want y in terms of x here. They didn't want y squared in terms of x. But you could write that as 40x to the minus 3 over 2, for example. That would also be acceptable. And yeah, etc, etc. I think I'll call it a day now for this video. I might do a few more on some of the earlier questions. The only one which really caught my eye, which I thought, oh, that looks quite good fun, was the triangle one with the semicircles. It was early on in the paper, so perhaps the proof isn't as hard as I think it's going to be. But I just suddenly thought, oh, that looks interesting. Like, they just said basically prove that that area, A, is the same as this area, B, and this area, C. It just looked like fun to me. It was like, oh, I've never seen that kind of I've never seen that idea before. I can see why it might happen because of Pythagoras, and certainly Pythagoras is what you're going to need here. So yeah, should we just quickly do it now? Because you know, it just looks like a lot of fun. Okay, what would I do for this one? Well, if we call this side, I mean, yeah, I think students will find this difficult because it's like, how do you do something like this? So let's do it. Okay, if we call this side A, and we call this side B, we call this side H for the reason that it's a hypotenuse, then we can certainly say straight away that a squared plus b squared is h squared. That's a very famous result. If you haven't learned that in GCSE, have a word with yourself. You know, that's definitely something you want to know. Okay, so a squared plus b squared is h squared. Now, what we've got to do is prove that the area of A is equal to the area of B plus the area of C. Well, okay, let's work out each of those areas independently, if you like. We can say h over 2 squared times by pi is the area of A. Yeah. Similarly, b over 2 squared times by pi is going to be annoyingly c, because I just wrote down the b there with a c, and a over 2 squared times pi is b. Yeah. So, you know, I'd have to actually explicitly state in the question, you know, let A, make sure you've been clear to the examiner anyway. When you're proving things, you really need to be clear, and I'm not necessarily the clearest mathematician, actually. It's something I've had to improve as I've started teaching. But, you know, essentially, annotate the diagram should be clear enough. But, you know, it doesn't hurt to say let A be the side length. Well, let's make it, let A, let me just, let A, B, and H be the side lengths or something like that. Make your argument clear. Maybe they wouldn't mind about that. I don't know. Okay, so then what are we going to do? We're going to say, okay, so if we start with area of B plus area of C, well, that's going to be equal to a squared pi a squared over 4 plus pi b squared over 4, which is equal to, and your proof might not look exactly like this, but could easily still be right. Factorise out the pi over 4 and you get a squared plus b squared, but that is of course h squared and pi over 4 h squared is what this equals, and so you can just say that equals area of A. Yeah, now I've done it quite quickly there, but it was good fun, that one. I quite like that one. Anyway, I'm going to stop the video now because otherwise I'll waffle on and the videos get too long. But I hope that helped for some of the tough questions on the first paper. I hope it will be useful to you anyway. All the best, and keep up the hard work, and best of luck in the next 2 GCSE exams. Hope it goes really well.